So as you can see, here is our original 2SA979, and here is our replacement 2SA979 that we made homemade. And I blew through both of them and made them before I realized that I'm going to get a bunch of questions how I did it. So I took out a couple of transistors and I'm going to make a third one on camera just so you can see how it's done. So the first thing we need to know is how the pins are configured on this 2SA979. And if you look at this little diagram here, it shows you that, let me back up just a little bit. This is how the pins go. So this would be sitting this way. And if you look, it's base, collector, and then the two emitters are tied together in the middle, and then collector, base. These transistors are 2SA or KSA 992s are emitter, collector, and base. So if we go ahead and we put these together in the correct configuration, we can have one transistor facing one way and the other facing the other way, like that. We can actually get that configuration. So we're just taking the two transistors here, turning one over so they're back to back like that. We're going to put this into the little helper hands and we're going to solder the center pins together, and I'll do that right now. I now have them clipped together, and I'm going to do this around the camera, and really, of course, looking through the camera is not as easy as, but all we want to do is just tack the end together just a little bit like that. That's it, nothing else. And we may even remove that later, but just to hold it, that's all we care about. Then we take them out and drop them, of course. And then we put them in the helping hands like this to kind of hold them steady. Now, you can bond these together with two-part epoxy, like JB Weld works really well. You can actually use two-part epoxy and put a little metal piece across there if you want to bond them even better. Although just putting them in a blob of JB Weld would work perfectly. I'm just going to use some stuff I've had around for a long time. Don't ask me how to read this. Don't ask me where I got it. I've had it forever. A little tiny, I have probably 4 or 5 tubes of this, and it lasts an extremely long time. This is the first one I've opened, and it's just tiny little bit, goes a long way. This is thermal epoxy. They're thermal glue is what it really is. It's not epoxy because you don't mix it. But it's very heat conductive, and you just take a little bit of it, and I think you can buy this on Amazon or eBay or, you know, all the normal haunts. And you just spread it on here, and within a few hours it actually hardens. And not only does it harden, but it is pretty thermally conductive. I mean, this is the kind of stuff they use in industry to glue a a semiconductor or something to a heat sink when you don't. This is different than thermal tape because it's glue, but if you wanted to glue a little heat sink to a little chip or something, this is the stuff they use. And so there you go. Then I take a little piece of heat shrink tubing like this, and I just cut a little piece off. Snip. And I put it over the whole mess like that, and just let it kind of rest on there. Then I'll take the heat sink or the heat shrink gun, the heat gun, shrink it down, and that's going to kind of hold all that thermal glue and everything together. And that's it, it's done. Simple as that. And what we end up with is a nice little 5-pin chip that works just the same as that original 2SA-979. Whoops, help if I stayed on camera, huh? So there you have it. That's how you do it. We're going to now place these in the board, and they'll work just the same as the one that we took out. And there it is installed, and you can see, other than the heat shrink stuff, it actually kind of looks like it belongs there. And when this stuff hardens, you can see it just forms a really nice little bond. So these are going to thermally track together just like that package that the original. Okay, so I'm going to get all the rest of these transistors replaced now, and then we'll see where we are. So here's our board with all fresh transistors and diodes and so forth, and everything's cleaned up, all set to go. And we are going to get this mounted up and see what happens. Alright, everything is back together, and I have 2 meters connected to the DC offset and the bias adjustments. And you're going to see this turned on for the first time along with me, so if something goes horribly wrong, you'll see it. I have 2 main concerns. Concern number 1 is that we replaced a bunch of transistors, and when I took this thing apart and measured it, the DC offset adjustment potentiometer was almost at the end of one of its range on one direction. So that tells me something wasn't totally right before. I think that's why we had the drift on the DC balance. Secondly, if you remember, we replaced those 2 stabilizers in there, the onboard ones, not the ones on the heat sinks. And we're going to experiment and see how they work as substitutes. Now, I have a feeling that they'll work, but I also have a feeling that it's going to throw things off a good bit. So we're going to need to check that as well. So we're going to do all this, and let me get turned on to the meter up here, put you on the meter, and we'll turn it on and see what happens. Top meter is going to be DC offset, and bottom meter is going to be bias. Remember, this one we want to be 0 volts. We're going to set it here to the 2-volt range. And this one we want to be about 30 millivolts. So let's turn it on and see what happens. I think it's going to be wrong, but we'll try. Okay, offset is way off. Let's go up and see where it was. I turned it off here. And I told you I thought that was going to be a problem. So let's make some adjustments here now. Hold on. Okay, I am on the potentiometer, and we are going to turn this on again, and we're going to adjust it for the DC balance. You can see we're not getting much of anything right now. So let's see if we can adjust. We have no bias right now. So let's see if we can get it to turn on. Nothing yet. Let's see, go the other direction. Nothing. So something's not right in here. So we got something wrong. Let me check something. Okay, once again, clearly the wheel was turning, but the hamster was dead. Yes, we forgot to plug in the connectors on the bottom of the board. Even though I diligently connected on the connectors on the top of the board. So Now that we got past that Tony idiot thing, let's try this once again. Get set up. Alright, here we go. And that is not good. Let's see. We are getting DC offset, so let's see if we can adjust that. Okay, and the pot was almost maxed out, like I said, from the original, and you can see it's adjusting perfectly. And we just got, there we go. How's that for offset? Let's bring our bias up to our 30 milliamps, or 30 millivolts. Okay. And we're going to let this warm up a little bit. I'm going to keep it down around 25 millivolts because it's going to creep up with temperature just a little bit until it settles. And the main thing I want to see is if the offset drifts on this. I'm going to set it as close to 0 as I can get. Oh, just went over. I think right there's about it. That's about all we can get out of it. So 3 millivolts, I'll take that for DC offset. How about you guys? And we're just going to watch the bias here for a little bit. You can see it's climbing, and that's normal as this thing warms up. You usually have to wait about 10 minutes or so. I like to wait closer to 20 minutes to kind of see where it settles in. But we'll take it back down a couple. Like I said, we're only moving, millivolts at a time, but it looks like a whole lot when you have a meter with a lot of digits. It makes it look like it's creeping terribly, but it's really not. And this is going to keep happening for a while. And as soon as it stabilizes, we will come back. And you can see even the DC offset is kind of settling in. The good news is the pot is now closer to the center of travel on both potentiometers, and those stabistors are working. They are working correctly. Now remember, these are not the thermal tracking ones that are on the heat sinks. Those are the original ones that came with the unit. I'm talking about the ones that are on the board that we built our little ones on the little circuit boards. We're going to try those to see how they work in this circuit. So give me some time, and we're going to let this settle for maybe another 10 minutes or so, and we'll come back. We are nice and stable now, so I'm going to refocus you down to the scope, and I have the signal generator and the dummy load connected, and we are going to look at the left channel, which is the one we just rebuilt, if I can get the camera here to cooperate. And we're just going to see how it looks for crossover distortion and so forth. Alright, I got everything. I think it's all on. Turn on the signal. Okay, here we go. First time. Look at that. And there's about 3 volts. So that's not, we're not working it real hard, but as you can see, so far so good. This is, I'm on times 10, but for some reason my meter isn't, the scope isn't automatically switching. It's something in the settings. I'm just not going to mess with it right now. Just so you know, let's bring it on up. So right there is 40 volts RMS, right? 39.3. And It's too early in the morning for me to know what that is, so get the calculator out. Let's see. What did I say? 39.3. And then we'll divide that by 8 ohms. 193 watts. Okay, so was looking pretty good at 193 watts there. It's been a long week, guys. My brain is mush. This was a long week at work, so but anyway, yeah, this thing's looking good. And look at this, after heating it up a little bit, our bias has actually dropped slightly, which is really good because that means that the thermal tracking is holding. And if we go up to our DC offset, it's staying pretty nice. We'll give it a little touch up, although I think it's pretty close. Let's see, wrong way. Yeah, see, it's just kind of, there we go. So all is looking good. Bias is holding perfectly now that it's warm. And I think this was a good restoration on this channel. So I'm definitely going to do the same thing to the other channel now, because those stabilizers work great. All of the choices in transistors I chose seems to be okay. Of course, we're going to need more testing after we finish everything, but I have a feeling this is going to be excellent. So all good news. And the really cool thing is, other than me forgetting to plug in those 2 plugs, we got it right. So that's always a bonus. All right, let me get on the other channel now and do the same thing to it, and then I'll come back and we'll do some final testing. All right, we're all back together, and both channels are rebuilt now, and the left channel no longer has DC offset drift at all. It's rock solid. I can turn it off, let it cool all the way down for an hour or 2, turn it back on, everything's stable. This channel is unchanged. I replaced everything on it, but it was working perfectly when I started. So I just did this channel just so it would match this channel, and just so that we didn't have anything happen in the future on it. So everything is done. I'll give you a quick little rundown on a couple of little notes. And as soon as I get my paper, I'll show you. For our transistor list, I did not have any BC556s, but I did have some KSA-916Y transistors, and they actually turned out to be a perfect match for what we needed for this particular. They're kind of overkill as far as power handling and so forth, but characteristics-wise, it was a really good match, and it worked very well for these 2 SA733s in this receiver. So changed a couple things there. Also for this 2SC869, I ended up going with a KSC-2383 OTA. The RTA would have even been a little bit closer, but it doesn't really matter in this part of the circuit. The main difference is this is a 160 volt transistor, just like the original. The 1845 is 120 volt, which really is more than adequate for where it was being used, but I had the transistors, so I used them anyway. Everything else is pretty much what we talked about. I noticed when I tested it on a square wave, just had a little teeniest tiny little bit of just a little noise spike at the very corner of the rising edge, and it only showed up right before you were maxing out the power into clipping, where you were getting up around 250, 270 watts. So what I did was I replaced this little capacitor, which is a 10 picofarad, and I replaced it with a 15 picofarad. I'll show you where it is in the schematic. It would be, where did it go? this little capacitor right here, and it just needed up just a tiny bit. It didn't affect anything at all. I didn't notice any change in anything else, and it just kind of helped tame that down. It wasn't even that bad, and you probably wouldn't have affected anything, because again, it was right when the amp was getting closer to clipping that it was showing up. But it was just a tiny minor little oscillation at high frequency, and it wasn't really an oscillation. It was more of kind of a little ringing peak spike, so that took care of it. Anyway, everything is working extremely well. This is going to go back upstairs on the speakers, and it's going to get another extensive test, and I have a feeling this time we're not going to have any problems at all. Everything else was perfect. So that's going to wrap this up then. We'll do a little sound demo when no one's home and I got time to crank things up and set up the microphone and all, and then we'll be wrapping this series up finally. This has been way too long on my bench. So that's it. Again, we'll do a little test, and then we'll be moving on to the next project, which is already set to go onto the bench. And we'll leave you hanging on what it is. All right, talk to you soon. I better turn that one down. Listening to a little bit of Grateful Dead, Blues for Allah. But, well, there it is. Let's see if we can do a straight-on shot here with the lighting. I don't have any lights, too many lights on in the room, but you can see how the cabinet came out. Really nice. And actually, this thing's so flat up here and level. When I set the the turntable on top of the receiver, and I put the level on there, it was dead level. So actually, it's this phono stage is awesome. So I almost feel like after all the effort I went through on this thing, it's going to be a hard thing to part with, because this thing was just so much work. Unbelievable. I normally would never go to this extreme, but I think, you know, it was worth it. I think we all learned a lot on this together, and this thing really turned out nice. I wish I could play more for you guys, but you know how they've gotten really strict with the audio stuff, and really the YouTube audio library kind of leaves a lot to be desired. But anyway, it is working very well, and I'm going to wrap up this video. We're going to call this one done, because I already have the next project sitting on the bench, and it's another huge heavy thing sitting on the bench. I'm getting tired of it, but hey, it's what we got. Anyway, thank you all for coming along on this incredible journey on this thing. I think whoever ends up with this receiver is going to just absolutely love it and have a lot of years of enjoyment out of it. And that's about it. So as always, I wish you guys peace, joy, happiness, and good health in your lives. I thank you for all the comments. I thank you for all the kind words. Hopefully I got some of the emails caught up to all of you today. And but that's kind of like doing the laundry. It never ends, you know. But that's okay. I don't mind a bit answering them. So this is the fun thing I do here. It's my hobby. So thank you all again, and we will be back very soon with our next project, and I'm not telling you what it is. You'll just have to watch and see. Thanks, guys, and take care. Bye-bye.